Okay, in this video we're going to use the discriminant to determine whether the roots of our quadratic equations are real or complex. Okay, we have to remember that the general quadratic equation is ax squared plus bx plus c equals 0, where a is the number in front of x squared, b is the number in front of x, and c is the number without a variable. We must also remember if there's a minus sign in front of any one of the numbers, then that number is considered to be negative when we're plugging it into our formulas. So again, a is the number in front of x squared, b is the number in front of x, and c is the number out here by itself that doesn't have a variable with it. Okay, our discriminant is part of our quadratic formula. It's the part that's underneath the square root symbol. It's just b squared minus 4ac. And when we plug in a, b, and c into this formula, if we come up with 0 or a positive number, then our roots are real. Now if we come up with 0, then we have a double root, which means the root is the same, but it's still a real number. If we come up with the discriminant that's a negative number, then our roots are complex. And that's all it is to it. Okay, so we'll take this example. We have x squared plus 8x minus 10 equals 0. And we know that a is 1 because that's the number in front of x squared. B is 8 because that's the number in front of x, and c is negative 10 because that's the number out here by itself, and it has a minus sign in front of it. So we'll take that, we'll plug it into our discriminant formula, which is b squared minus 4ac. So 8 squared minus 4 times 1 times negative 10. So we'll simply plug it into that formula and then we'll simplify. So I have 8 squared, which is 64. Then I have negative 4 times 1 times negative 10. Now since two negatives are being multiplied, that means our answer should be positive 40. Add those together, we get a positive 104. We're not really concerned about the number. We're more concerned about is it positive or negative? And since this number is positive, then that means that our roots would be real. Okay, so we plug it into that formula, b squared minus 4 times a times c. Work it out. If it's a positive number or 0, roots are real. If it's a negative number, then the roots are complex. Okay, let's look at this one. We have 2 to the 1/2 power times y squared minus 3 times y minus 8 times 2 to the 1/2 power. Now don't let these 1/2 powers confuse you. Remember, the bottom number in a fractional exponent is just telling you what the root is. So that's the square root of 2, that's a, negative 3 is b, and then 8 times the square root of 2, because that 1/2 is just on the 2, so 8 times the square root of 2 is c. So let's plug this into our formula and see what it looks like. So we have b squared minus 4 times a times c. So that'll give us positive 9. Now over here with all of this, we can multiply our numbers that are not under the square root times each other, and we can multiply the numbers that are under the square root times each other. Keep in mind we only have one negative number, so our answer will be negative. So let's start simplifying this sum. Let's say that 4 times 8 is going to give us that negative 32. And let's multiply the square root of 2 times the square root of 2 gives us the square root of 4. Now we know that 4 is a perfect square, so I can take the square root of 4 and change it to just a regular integer, a regular number. The square root of 4 is 2. So now I have this 32 times 2. So I get 64, or 9 minus 64. Then 9 minus 64 would give me negative, since the negative is on the larger number, negative 55. So since my discriminant is negative, my roots would be complex. And that's how you would work that. You just plug those numbers into your discriminant formula and you simplify. Positive answer or 0, roots are real. Negative answer, roots are complex. All right, good luck.